Good morning, everybody. Thank you very much for the opportunity to present today. I'm going to be talking about something slightly different. I mean, there's been a whole lot of fishery stuff this morning, and I'm going to now take to the skies and tell you a little bit about some of the research projects that we've got running, well, at least one research project. Just to provide a little bit of background as to who I am, I manage a program for the Endangered Wildlife Trust that looks at wildlife and energy issues, and our primary project is the Eskom-EWT Strategic Partnership. And so we are responsible for the mitigation of the power line infrastructure that you see across the country, making sure that we can minimize some of the effects or the impacts on our bird species specifically. We do this through a variety of activities, one of which is a comprehensive research program, and I'm going to chat to you today about one of our projects. It's not a very academic study at this stage. We haven't analyzed any of the data. So what I'm going to present is just a couple of maps to show you what results we've got so far. But like I said, there's no hardcore statistical analysis on this, so I hope you enjoy the presentation. So just for those of you who don't know, what are the common interactions that we have with power line infrastructure? The first of which are collisions and electrocutions. These are quite obvious. We have birds colliding with overhead conductors, birds being electrocuted on the pole structures themselves, and we also have a whole lot of wildlife mammal electrocutions, at least, on the power line networks. In addition to that, we have an impact that actually occurs on the infrastructure itself. It's the impact that the wildlife has on the network. And this is through streamers, so it's the birds defecating on the insulator strings. And then the second one is nest-induced faulting. So where we've got birds nesting on critical or within critical spaces on the infrastructure, that nest material compromises the performance of the power line network. And the last one is habitat destruction and disturbance. And this really occurs as a result of the construction of new power lines or the maintenance thereof. And it's really around the vegetation management that they employ around the network. The one I'm going to focus on today is really around collision, specifically with regards to our large terrestrial bird species. One of the activities that the partnership employs is a central incident register. It's a database of all the mortalities that we have recorded across the country. We rely on ad hoc reporting from a variety of sources, primarily from our EWT field workers, as well as the general public, and then the Eskom Field Services staff. To date, we have a little over 4,700 records, and we've been collecting this data since the inception of the partnership, which was in 1996. I'm just going to bring up these two, and I'll come back to why I've listed the blue crane and the Ludwig's busted specifically. But it just shows you how many of the recorded mortalities that we have can be attributed are blue cranes and Ludwig's busted. Now, we recognize with the register that there are a number of problems with the data that we're collecting. And because we rely on ad hoc reporting, we are assuming that we're having this iceberg effect, that the data that we are getting in from the various sources is really just the tip of the iceberg and represents a very low percentage of the actual mortality occurring across the country. It's also subject to a whole lot of biases, in that a lot of the data, the majority of the data that we get comes from our EWT fieldworker network, and they are responsible for key species like the blue crane, so we get a whole lot of blue crane mortalities into the register. It's very specific to geographical areas, particularly where the field workers are present. So if we have a look at the transmission network, a little over 30,000 kilometers of power line, and then if we switch that to the distribution network, where we have over 300,000 kilometers of power line, you can see that that 4,000 odd records that we have in our register is probably tiny in comparison to what is actually happening out there. So with that in mind, we realized that what we needed to do was start to collect data in a more systematic way. And the only way that we could do that is if we chose a couple of sections of power line in a key area where we knew that the species that we wanted to study occurred, and we systematically surveyed those lines over a period of time so that we could establish some kind of collision rate for the species in those areas. So we established this research project, and we wanted to answer the three key questions that you see up on the screen. And really it was just to establish what the collision rate is for Ludwig's busted and for blue crane. We wanted to assess whether there was any way in which we could mitigate these lines. We currently employ power line marking, and we wanted to test whether the way in which we were doing that was correct and adequate. And then we also wanted to test whether the devices that we are using and that are approved by the utility are in fact effective in deterring birds away from the line. What we wanted to do then is to collect at least a year's worth of baseline data that we could then go out and mitigate the power lines thereafter, and then collect at least 1 year's worth of post-mitigation data to see whether there was the effect that we were hoping for. So in terms of the study site location, we chose the once busy metropolis of Dar, not so busy anymore. It is busy for power lines though, and that was one of the reasons why we chose it. You can see that there's an extensive amount of power lines going through the Dar area. It is in fact the backbone of the transmission network in South Africa. So we chose these two lines, or these 4 sections of line, hydroduraphy 1 and 2 and hydroposeidon 1 and 2. The other reason for choosing Dar is that we had field workers present as well, so we could make sure that these people could go out every 3 months and make sure that they collect the data systematically, because this is what the study relied on. In terms of the data collection, we had field workers go out and they drove series of power lines, and then they also walked sections in order to account for the detection bias. But what we did was we collected all the sort of data that you can see here on the left-hand side. Every time we came across a carcass, we date and referenced it. We collected bones and feathers for analysis afterwards, just to make sure that we could age and sex the species that we were collecting. We labeled what species it was. We took notes of the tower numbers, the GPS coordinates, the distance from each tower, and the reason why we did that in conjunction with the height of the conductors is that we assume that the collision occurs mid-span, so at the lowest point where the conductors hang, or the earth wire at least hangs, and we wanted to test whether that was in fact happening, because when we ask Eskom to mitigate the power lines, we ask them only to mark the middle 60%. If, however, through this study we find that we are finding carcasses much closer to the towers, we would then be able to change that mitigation strategy, but we needed to test that assumption. We then looked at the vegetation type and the topography, and the reason for that is that we want to, in time to come, be able to predict where we can expect to find collisions occurring. So it was very important for us to be able to find out where we are finding blue cranes and where we're finding locust bustard, particularly with regards to the vegetation and topography. And then we looked at the absence and presence of power line markers. In 2000, a very similar study was conducted by Mark Anderson. But unfortunately, through no fault of his, Eskom put the wrong devices up on the power line, so it rendered his study pretty useless. So this is why we've now re-established this study. But we needed to account for those areas of power line that were marked, and we needed to see whether birds were in fact colliding with those sections too, particularly since it was the wrong device.
7 minutes.
Great stuff. I have to speak really quickly, so I'll have no problem. In terms of what we found, through 3 years worth of baseline monitoring, so we landed up not being able to monitor for just a year, simply because we couldn't get Eskom to employ the mitigation fast enough. So because we couldn't get them to do that, we were able to monitor the sections of power line for at least 3 years, and those were the statistics that we got. And the reason why I brought this up here, and it links to one of those previous slides that I had, is that you can see within 3 years of data we collected 229 blue crane carcasses. And considering that we've only got 900 in the register over 16 years, in 3 years we managed to collect a little over 200. And that's only on 200 kilometers of power line. So we can already see that that iceberg effect is definitely happening. We were able to then establish the collision rates for the two species, and the locust bustard one is a particularly worrying one for us simply because it is quite high. And given that, speaking about how big that network is in the Karoo region, we know that this species is in trouble, and it's perhaps the black rhino of the bird species. Sorry, this graph may not be too clear simply because the blue crane is being denoted in blue, which is difficult to see on the blue background of the power line. It wasn't on purpose, but anyway, this is just a spatial representation of where we found the carcasses on hydroposeidon, and you can see that we've got a whole lot of yellow dots there for the locust bustard, and I can assure you there are a ton more blue crane carcasses on those power lines. A very similar graph for hydroduraphy, just showing you where we found everything. And then the fun began. Now that we had all this baseline data, we now had to establish some statistically kind of robust marking protocol that we could make sure that when we test the devices, we know that we are getting the right data back, so that we know which of the two devices that we are using is most effective. So this might look very simple to most, but it took us probably 8 to 10 months to try and develop this marking protocol that you see up at the top. And it relates to the 2 buffers, the 4 spans of flappers, more buffers of control, BFDs are bird flight diverters. It's the spiral you see in the right-hand corner there. Another control, and then some more buffers. And that's how we employed the mitigation. This is just a series of photographs just to show you the process. Eventually we got Eskom to go out to site, we bought all the devices and we got the fleet out there and the marking began. Tons of team briefings, both from the Liveline team. The Liveline team is quite an interesting setup. The guys work Liveline, the line does not get switched off when they're up there, so they wear a completely conductive suit filled with copper wire. So they are charged at 400,000 kilovolts. Very interesting process. The EWT briefings were a little less formal, some people heading off there, others talking, and then obviously the briefing with the pilots. There was a host of logistical things we needed to get ready, and this was just sorting out the flappers. We had some strapping men that were able to open these things up, which was great. For some of us who weren't so strapping, we really had to tuck in there and get these clips open and get them ready to go up onto the lines. Sorting out of the BFDs, we had to put them all out of the designated landing zone to make sure that the pilot or the pilot's assistant could just rush out, get them all into the chopper, and off we go. And then they were off, which was good fun and was really nice to see this all happen. In terms of the implementation of the flappers, it took just over 50 minutes to put 180 flappers onto 4 spans of power line, and predictably, with regards to the bird flight diverters, it took considerably longer, simply because they've got to actually physically wrap the spiral around the earth wire. Some pretty nifty flying. There are only 3 pilots that can do this sort of proximity work within Eskom, so this is why it took so long for us to get the devices up. And then, fortunately, I got to go up into the chopper and have a look at the results of our effort, which was quite good, just to see what the bird flight diverters look like up from the sky, possibly what the birds are seeing, hopefully what they're seeing. In terms of our post-mitigation results, the results are quite clear. It's really nice to see that our blue crane mortalities, although 43 for the year, only 5 of those have been reported under the lines that we've marked. With regards to Ludwig's busted, a little less. We don't have a big sample size for Ludwig, so we don't really know whether the markers are working for them, but we do know that it is working for the blue crane at this stage. Just in terms of the treatments on the power lines, you can see where the blue crane and the Ludwig's busted are occurring. A lot of them are occurring in either the buffers, which is the red zones, or the controls, which is the grey ones, which is really, really nice to see. Particularly that one there where you can see the big conglomeration of blue cranes on that side, and a similar representation for the other power line. We opted not to mark this power line here simply because there are 2 power lines running very close to one another. And it's also our assumption that placing power lines close to one another has a mitigating effect. So we didn't want to skew our results by marking a power line that was possibly already being mitigated by the other one being so close by. And thank you very much to all the people that
Thank you, Megan. Excellent work. Thank you, team. It's great. Any questions? Okay, Athel?
Megan,
Yeah.
I find those figures mind-boggling, and you said there was something like nearly 1.5 Ludwigs per kilometre kilogram,
Yeah.
and that seems to be in an area which has the fewest pylons in the country.
What the
Compared to like in the east where you've got Denham's busted and it's
Absolutely.
just a red massive pylon.
Yeah.